John, if you want to take it away.
Stella, actually, do you want to do the intro since this is kind of your RFC?
Sorry, I was typing a comment. Yeah, can you, so let's see. Sorry, caught me off guard. Can you go to the next slide? Yeah, so we started this conversation a few weeks back in a little bit of a backwards order by presenting our work on, pulling all this together and then acknowledging that this was really a symptom of missing development upstream. So if I were centering this, y'all can read the slide, but I think we should be pushing for upstream program representations for some of the modern frameworks. I think that this could really bring some unity to areas that are pretty fragmented right now. And those of us who are spanning these framework gaps and runtimes are increasingly going to dire lengths to, spell function the same way or spell module the same way and spell global the same way and all of these things. So I would like to see us, create a spot for this discussion to happen upstream, design it, start playing this forward. And just a little bit of feeling on this. This is intuition, but it is informed, is that the ML program and runtime space used to be a bit of the Wild West. It used to be very, very different. And I think that at this point we can actually design this and draw a line around it. It might just be that I've been in this for a little bit too long, but I think that we can make some decisions and make progress here in a way that we maybe couldn't have a couple of years ago. So next slide. Sean, do you want to take this?
Yeah, sure. But very quickly, I think it's worth framing this discussion. We're not trying to solve the world here. And, there's many possible layers at which we could converge things upstream and, many different layers of abstraction. I think what we're shooting for now is actually aiming maybe a little bit lower on the abstraction level, just because that's where things tend to become sort of more mechanics and less opinionated. So I just wanted to frame the discussion where, deciding what not to put in here is, equally important. And kind of, again, my kind of gut feeling on this is that it's going to be a little bit on like the lower end, like a bit closer to the runtimes abstraction level. So yeah, just to scope the discussion.
Could you share kind of what you, I mean, there's many things one could do here, but what is the most valuable, or what do you see in terms of standardizing ecosystem and helping interchange? Is it low level? Is it high level? Is it?
I think so my opinion is it's a mid-level that that standardizes the spelling and the common structures between a set of runtimes. So I would. I think that when I've seen this spend a lot of time in the past, we've either focused on ops, which are a very
different can of worms. Yeah,
different can of worms. Important, but there's a lot of things there. Or we focused very high level on graph formats, and we talk about optimizers and very ML specific concepts. We're at the point now where I think that we've got quite a few people in the industry building effective ML compilers in various fashions and hooking those up to building runtimes, inheriting, whatever, building those and either focusing them on single node or scaling them to large systems with various techniques that decompose. But the lack of a program representation, the lack of, Sean will get to some of the things, means that we're creating software that tends to be inverted because you end up with the runtime exposing some of its structures on this, and then you end up with a front end like taking runtime dependencies. And I'm seeing a lot of dependency inversions that I think that we can by pushing upstream we can flip the right way.
Well, I guess the reason I'm asking is that we all see, or I assume we all see the same things, where we're all re-implementing the same things over and over again, right? Not sharing very much of it because of reasons. I guess the defining the problem piece seems like it's a really critical part to this, right? Because one of the reasons people are building different systems is that they have different constraints and requirements, right? And so somebody focusing on usability and drop-in replacement would be different than somebody that just wants to get the tiny subset of something working to unblock their, the two ops their accelerator can do, kind of a thing, right?
Yeah, no, exactly. I think that just one principle here, and you say this all the time, is embrace the weird. But if we want to embrace that, we do actually need to create some channels for this thing to go in.
Well, and again, one of the superpowers of MLIR is that you can both have the standardized lowest common denominator that covers the 90% case, but then also allow dialect specific, like other dialects, to mix in and say, okay, here's the weird thing that's not covered by the generic case that's nonetheless really important for me.
Yeah, absolutely agreed. And I think that I think that the difference between when we said that a couple of years ago or a few years ago and now is that there's a lot of people effectively doing that, and starting from a 75% plateau and specializing. But we're kind of, and we got this in the MLIR China meetup on last weekend. That this was one of the top questions was what are you doing to make this less of a circuitous path from component to component? So.
Also, but the flip side of this also, and one of the reasons why I care so much about the design aspect of this, is that it's really easy to accidentally conflate things.
Yeah.
Right? And so again, I'll let Sean take it away. I don't want to interrupt you too much, but just figuring out how to separate things so they compose correctly is really key.
Yeah, no, I mean, I completely agree. I mean, that's why I basically presented last week, hey, we solved this once with Erie's input dialect, and I think we should throw it out and start over. It's, like I'm watching multiple people solve this, and each one has like a little piece of it, but including ourselves, and we should step back, layer it right, design it right, and start with something fairly minimal and structural that lets us get some convergence and get some things going.
Mm-hmm.
All right. Yeah, actually, Chris, I have some just like probably like a later slide to your point. But let me continue in the order that we have it here. So the initial RFC was pitching adding an ML program .module/func, and I think one of the reasons this is really important is because regular wherever it lives now, not STD or the built-in module in func is don't pin down certain important aspects of considerations that we need to care about in like most classes of programs. And so the anchoring on this, so at least like we have a place to like, put a comment saying like, okay, concurrently invoke this thing and they access the same state, then there's a race, or we guarantee something about it. Like we currently have a place to even like document such expectations. And so this is a place where we can sort of just start to tighten, tighten the screws on these abstractions and build further. Yeah, and just as a grab bag of things, I don't have very many more slides, so this is just to seed the discussion. So I'm going to just go through it pretty quickly. Just see some thoughts on, so ML programs, large externalizable constants, sort of statefulness, non-tensor types are a very frequent thing. Control flow, some sort of notion of like a mutable tensor, like sometimes comes up, which is needed for interoperation, and of course the actual tensor compute ops, but that's just not a focus here. And I think really, like, if there can be one outcome for this is that this discussion today is not that we should not necessarily like immediately having a story for it, but just sort of unsticking like the getting the ball rolling on these things upstream, sort of like a common recognition that these are features that we want to support in upstream MLIR in some form, and then turn it into like a technical problem of discussing that.
Well, and one of the things that triggered me, and I think you, Day, as well on the list, was you get into the non-tensor types thing. That seems like a very orthogonal ball of wax that also important, but it's kind of like ops, right? It's a big thorny problem. There's a bunch of questions there, and it'd be nice to make progress on one axis of this space without having it bogged down with trying to solve all the world's problems.
Yeah, I agree.
I mean, I would ultimately, I'm going to agree and slightly disagree. One of the things I agree with is that the non-tensor types should probably have a similar level of a just the types thing that we say with just the ops, but that like we have tensor type, there are some fundamentals here that are a bit more universal, and that I don't think we should get to them in one step, but we should be willing to accept that there probably is one or two types that do transcend the category a little bit, and that we should spend some more time on when we get there.
I mean, I totally agree with you in concept. I'm kind of concerned about the details on that, because in something as simple as a list, right, is domain specific, and I 1000% agree with Sean's point about like using the standard func. There's a whole different discussion about that. But using standard func doesn't allow you to nail down the constraints. And I'm concerned that if you say like, okay, we have a generic list and it's not nailed down, and everybody just defines ops against it, that run into similar kinds of problems.
I agree. I mean, I've behind the scenes, I've been dealing with grousing about this for years of like, why doesn't MLIR just have a list that would make this stuff work better? And I'm usually like, which list? And that's a very loaded question. I do think that there has been thought refinement on this over the years, that we can walk forward and that there is a meaningful reduction. Like Sean put scalars and lists and dictionaries on here. I do think that if there was one type that is closer to some consensus and some low level thing, we have more mileage on the list abstraction these days. But like, shouldn't solve it right now. We literally don't have a place to put this. So
I also think that these things are inherently, so I think it's important to have a separation between like interfaces and implementations, right? You can imagine having like a list type and, so many discussions about, how you want to transform it and all this stuff. Whereas I think from like an interfacing perspective, I think that there's certain simplifications to the problem, especially when you sort of really boil it down to like, mechanism rather than sort of policy. And I think just figuring out how we want to approach this, it's like, are these going to be like more or less pure interfaces with just bare bones sort of complete functionality, or how do we want that to look? Could be an interesting discussion point. Nicholas?
Right. I think I'm essentially going to make a point that's very similar to you, is that having a notion of a list is not the same as optimizing it in MLIR. So we could very well have a type that allows you to have the functionality of a list and have whatever C++ implementation behind it. We don't have to do everything in MLIR immediately. I guess in the same way that Art has been doing for the sparse tensor type of things.
Russell?
So maybe this will get clarified in a little bit, but I just want to, when you say mutable tensors at ABI boundaries, I think there's a lot of other stuff that's not tensors that we often want to pass around. And as we've been thinking about things on our end, there's frequently the need to sort of model opaque structures that are getting, passed back and forth between things. And so often those are, actually buffers, but forcing them to take like a consistent format as you go back and forth across the boundaries is, can incur some unnecessary pain. So I'm curious if we would also want to model just this, a notion of the way that I might think of it is the notion of something that is convertible to a buffer or one of these generics, but isn't necessarily in that form.
I think we don't need to, I think we can do one better, which is actually allow you building, you who are building your compiler to plug in your own type here. So for example, like just to like shamelessly rip off Erie's design, right? It's like, so Erie has, this sort of uniform reference counted concept in its runtime. And, you have like a container type, like a ref of a thing. And, we could have like an opaque sort of thing, which is what mlprogram.func allows you to, pass along its ABI boundaries, that it has some sort of lifetime design, and then, or something. And then, we could provide, like, say we provided like a list that plugs into that machinery or that allow list. And then, we could also have a way for you to provide your own type, whatever that makes sense for you.
Yeah, and
I think that makes sense. Yeah. I think as we've been thinking about it, it's just like there's both value in having a way to reason about, mutable tensors, but there's also value in being able to not reason about them. So we have situations where it's like we're passing something, unfortunately, between the, more or less the same backend multiple times. And we don't want to, so for example, if I'm scheduling a bunch of TensorFlow execution, while I could model that as a generic buffer and, convert from TensorFlow into a generic representation and then, do one step and then convert it back into TensorFlow. If I'm sequencing a bunch of TensorFlow stuff, it would be great if what I really want is to leave it as this, and maybe that's exactly what you're saying, is leave it as this very opaque wrapped structure that I can request it as a buffer if I need to, but I can also just pass it around.
Yeah, well, I think
that's what I want. So I want this big thing that I can tell it to become a buffer if I need it to.
I think the principle that Sean and this discussion are really going towards is provide tools in the box that one could choose to use, but not force you to use them. Right? And so the standardization goal really helps because, like, again, there's a lot of commonality in the ecosystem, but it's not lowest common denominator, right? If you have a system that doesn't care about lists, for your bare metal embedded system or something, you don't care about lists, don't use lists. It's fine, right? If you have your own completely crazy list that doesn't really fit the model, then go invent your own list. It's fine, right? And so long as these things compose, it should be okay.
Suraj?
Sorry. So I'd like to raise a point over here. I've been working on this area too internally, and one thing we wanted to do was have very clear statements about what's required for the runtime when it comes to defining these at a higher level. For the case of mutable tensors, for example, there was an internal conversation about this. Does it mean the runtime needs to implement a heap, or could mutable tensors be exposed very trivially by defining those tensors to be both an input and an output to the program, which means they could be modified once and put out, and the next iteration uses them as the input again, but the modified value. And then questions around whether the modification entails a partial write or whole write to the tensor, change to the shape of the tensor, things like that. They all mean a lot of problems along the way. So it's important to be clear about those.
Right.
Yeah, I think that that we just covered about 15 miles by saying mutable tensors in quotes. And the if we were to principally decompose that, it would they're basically the most fundamental thing is that the disconnect that we see today is that most people that are shipping these programs around are shipping around a literal built-in func with the built-in tensor type, and that maps to nothing that exists in reality. The things that exist in reality where these programs are going are backed on either host or device memory in another memory space with a bag of memory and metadata on top of them with lifetime. Like there's a stack of these attributes that are the thing, and you can pick and choose whether these are constant references, whether you're doing destination passing style and passing in versus transferring ownership out. But we've literally not even created the nouns for this equation yet, and kind of need to go down that path.
Chris?
I'm not sure if it's time to move on from list. I know it's Sean's favorite topic, but I'm just curious how you're thinking about this. like pre-trained weights. I see a lot of people representing them as just this massive dense host tensor in models and things like this, which isn't super ideal for lots of reasons. I think that there could be room to help standardize, here's a reference to an external thing.
Yeah.
and then also have there's an MLIR plus a bunch of binary data thing going on. I don't know do you consider that to be part of the goal of what an ML program is, or is that something that's interesting to you?
I think that would be an interesting demonstration that we've kind of nailed down some of the principles of developing this, having a home to put that, because we've been talking about that since, day one, and we just literally didn't have a place to put that or incubate the development of that. So I think an ML program dot external constant that, interops nicely with ML program dot module or whatever. And, I think that would be a really interesting sort of MVP, just the sniff test that we're unblocking development in this space. So I think it's well within scope. Stella?
Yeah, I would go so far as to say if we only accomplished that, we would probably be able to pat ourselves on the back and say we did a good job. A little bit more there. I worry about this one a lot because it infects the design so much downstream. The way that we deal with inline tensor constants is not good. It creates all kinds of compiler performance problems. We keep trying to shove more things into the op folders and canonicalizers that aren't really cost model neutral. And on the Erie side, we solved this and can't this needs to be upstream. We've partially solved it, but we need to nail this down upstream. We need to get the my opinion is that there's probably a couple levels here. One is that we do end up with externalized constants with good infra for disk that we then probably also need to follow that up with.
Oh, you just dropped out for about 10 seconds.
Oh, sorry. Can you hear me now?
Yeah.
We probably need to reinvent this constant externalized thing so that we can actually reason about it on disk or otherwise. And then we need to look at the actual infra that we have for dealing with constants, which was really meant for dealing with small scalars and other things, and stop abusing folding and canonicalization for this is basically it. And we've got infra for this that we would love to have a conversation on to upstream, but there's no place to even anchor it. I do think that, again, if we were covering 15 miles in one discussion, this is related to the concept of globals. So, or an ability to have a mutable, at runtime, global large tensor storage. And when I've seen this in practice, when we've built program compositions for JAX and PyTorch and whatnot, we oftentimes start by saying these things are mutable globals. We then sometimes have the ability to say, have the programmer say, make this a constant. Just I've got a I know I'm targeting this for an inference case. I'm not going to give you an ability to set it or anything. And then we promote those into various levels. I'm saying we Erie plus various front ends promote those into more materialized constants that are able to be functional in the program. So there's similar to the mutable tensor at ABI boundaries thing. There's 15 miles of design work here too that we need to start walking forward, but we should.
Well, so the reason I bring this up and kind of my meta concern opinion about this whole conversation is that there's not 15 miles of design space. There's 15 miles across 20 dimensions, right? And so I feel like one of the concerns I have is if we overscope this to try to solve, for example, lists, to just touch on that, right? And we spend all the time talking about lists. We don't define a starting point which we can then scale, right? And if you instead scope this to, we need a module, we need a better function, and then we need a way to refer to external globals, right? Something super modest.
Yep.
Well, as you say, that's quite a bit of design space right there, and the infra required to do that. It's not solving all the world's problems, but it's a really useful baseline that then you can say, okay, let's go spend 6 months debating control flow, right? Another really interesting, very loaded kind of a concept that that is kind of orthogonal to the container kind of problems.
Yeah. So I mean, I think I'm wholeheartedly agreeing with you and using different words in some fashion.
Sorry. I'm sorry if it's coming across as I'm not trying to argue with you. I'm trying to like plus one a part of what you're saying.
Oh, okay. Then I think we've plus one each other a few times here.
Yeah.
So, I'm strongly in favor of laying a couple of these foundation pieces and then incrementally, designing it forward, because I believe that this is less branchy than it used to be, but it is still very branchy, and we need to not do terrible things again.
Yeah. So I mean, just to sort of bring this discussion to a little bit of a action item. Let's talk specifically about the ML program.func module, and like let's throw like externalizable constants in there. Like it sounds like we're converging on like that would be like a good sort of MVP to sort of get the ball rolling on these questions and see where and see our flow. Is that everybody else's understanding? Because I think at that point it's just sort of a matter of the technical design. All right, I'm getting a few plus ones in the chat, so cool. Yeah, it sounds like that's work that we can start discussing. Yeah, Chris says a good foundation explore the more thorny areas on top of. So I agree that because it gets thorny. Jacques?
Yeah, this might be digging into too much details, but you mentioned, for example, externalizable constants. And this is orthogonal to the work that's been done on elements attributed as an interface. Because, for example, it's reasonably simple to create an external constant today with an external storage by using that interface. I mean, I think we don't have an example of that upstream, but I think like 50 lines of code-ish to get something like works there. So is this something more general than that, or sort of like, am I digging into too many details?
I think it might be too many details. It just does sound like something that we need to do in like a thread, and be able to look up the code and cross-reference and stuff.
The way I would answer that, Jacques, is that right now it's very easy for people to go make their own things with that, but we don't have one thing that then helps consolidate and standardize a layer of the stack, right? And so, again, I don't read Sean and Stella's goal here as saying like let's invent new MLIR infrastructure. It's more about let's provide a set of dialects that allow us to consolidate a tiny part of this big mess, and then therefore get more leverage out of the ecosystem community and things like this. I don't want to speak for either of them. But.
Yeah, no, that's a good summary. That just beyond that point, we just because I have walked this path a few times now, there are infrastructure gaps, and like I'm somewhat eager to get to that point and solve them. And because we can't, we're currently like on the other side of a cliff here, and we can't see. We don't have enough development upstream on these things to put pressure on some of these harder points.
Yep, I agree. Okay, let me see what other slides I have here. Okay, yeah, just to, I don't know if this is exactly the most useful thing at this point in the presentation, but let me just zip through these. So, like we discussed, like designing, a stateless op from tensors. The tensors, MLIR, already has all the sort of, language to describe that type of interop. So we have toast and stuff. And so one way to think about this problem is to be like, well, just assume like multiplying comp, sort, FFT, any subgraph of such ops is just like condensed to just like a single thing. So it's like what's left in our programs. And so, ML really has evolved past networks, models, and graphs into being like actual programs. So you see state, control flow, and like honestly, just like miscellaneous logic that you would write in like a coding interview. surrounding graphs of the ML computation, and frequently these are a major cost per deployment effort. And so this sort of like glue code is actually like a major consideration for like kind of patching up the gaps. Actually, this like is a candidate name. Actually, it has been like a real name in a project I'm aware of for like this layer of stuff. Yeah, just to throw a few examples out there. They like to recognize hey, your favorite assistant. These audios come incrementally, and you like buffer them up, and you just like a ring buffer and things. So it's just regular programming, but these you start intersecting all these points. Like, I just want to keep like a list of like input samples or whatnot, or like I just need to update like a ring buffer or something. Same thing.
So Sean, I know you're going through use cases here, but this is one where to me, success in the early phase of this project looks like making it a lot easier to build that kind of system, right?
Yes.
So this is when you talk about, again, lists and things like this, and encoding the computation to enqueue things and all that kind of stuff. I mean, maybe I'm damaged from other things, but like there's so much variety in terms of, okay, if you're doing hot word detection, you're running a bare metal, tiny embedded system, the runtime for that's going to be really particular and weird, perhaps, right? And I don't know that standardizing the runtime interface is going to work super well if you care about those different kinds of demands. But anyways, I mean, again, I think that standardizing the program so that then you can innovate in the offset and be able to do stuff like that would be hugely valuable.
Yeah, I generally agree. It's the runtime interface here is very, very thorny design space, and I think we have to navigate that extremely carefully to avoid, either over specializing or uselessly generalizing to the point of uselessness.
Well, your point about tensor is really important and interesting. Sorry, I don't mean to steal from Suraj, but the tensor is interesting because it's a good unifying theory for a bunch of different things, but it also has open extension with the layout field, right? And so it kind of slices both. Here's the semantic, but then there's an implementation defined aspect of it as well that's open for extension. And so, there could be spaces in, the grand unifying list or something that maybe we could find a design space like that.
Yeah, I agree. Suraj?
Yes, so a bit of my problem over here that I'm kind of struggling to understand what part of this is really deployment and what's part of the sort of ML pipeline to put things together. They're typically two different things. Chris just mentioned embedded cases, really configured embedded cases where we might get a completely packaged model, a product buffer or fat buffer or something, and really no glue code or anything. It might run on something really constrained bare metal instances, and there's not a lot of bells and whistles to make it work. And in that case, a bunch of these things described here don't quite apply. So as was mentioned, there are different kinds of use cases, some of which require these and some of which don't. And that seem to suggest that there's something purely deployment, just a sort of prepackaged model, and there's a bunch of things that sort of hook into it and make it work together, like the connection to the speaker or the camera or whatever.
Yeah, so if I can restate what you're saying is that, sometimes there is sort of a wrapping code surrounding the invocation. Is that what you're saying?
Yep.
Yeah, and so I agree.
Separate things, yeah. And that's when you mentioned people spend time and effort on too.
Yeah, and so I definitely want to respect that. Then I guess one thing I'm saying here is I think the increasing trend is to move more of that into the model, just so then the compiler has visibility into it, and it's also easier for engineers to deploy. I see that as sort of like a wave that's coming.
I agree too.
And that's very dependent on the runtime. What the runtime supports. I think there's like 2 or 3 more slides here. So like for like speech recognition, it's very similar, but you have to do this sort of like tree search algorithm with ML in the loop. And so again, you just end up with just more like, I just want to write a for loop with like, appending to a list sort of thing, coding interview question. And yeah, these are just programs. And like, I think I've said this before, but we don't want this to spider into like a complete Python interpreter for sure. But I think the point here is, is there some like relatively unopinionated sort of mechanism layer that we can reasonably build here that unblocks the type of interoperation we want in the, for the community here.
And I guess I would say that's a non-goal to me, honestly. And at least if you're trying to solve this problem, I don't think that you're going to succeed. I'm just sorry, I'm being super blunt about that, because I think that, again, in the context of MLIR, right, where you're talking about a platform that's extensible and hackable and things like this, making it so that people can build these systems really efficiently and they can get high reuse, I think is going to be much more practical than saying, I'm going to have the right way to do, like the right programming model for all use cases that people can solve these problems with in the box, right? And I don't know that MLIR is going to be able to standardize like the right things for the same reason that if you look at TensorFlow graphs and they have atomic operations and all the different things, right? I mean, one of the concerns that I raised many years ago now is that they're trying to be like the universal compute thing, right? And the only really good way to be the universal compute thing is to know your target. And so anyways, I mean, I think that there's a huge amount of value in the standardization of containers. I think there's a lot of art in the circuit community that could also be useful to know about too, and we could share that if you're interested. But sorry, go ahead.
Yeah, plus one. I think that that the staying away from the universal compute axis, or at least only being in the position of choosing that 5 years down the road, if there is something that emerges, is where you want to be. We don't want to be innovating in the common abstractions here and innovating is in a strong quotes on that. And also big plus one on looking at circuit. I think that there was I think a lot of the folks in the ML side have not necessarily been following that development, but that's where you guys have been working out a lot of these how do you use this stuff in practice bits. And it might be a good idea to have a bit of a walkthrough for the folk, join the domains a little bit, because I know I've been watching that and derive insights from some of the design. So we don't have a lot of solid worked examples of the how you apply the generality in practice, and circuit is one of them.
Stephen, I think you were next.
Just, I guess maybe to put a counterpoint to what Chris says, I think the way I see this is that there's differentiating and non-differentiating stuff. And there's a bunch of real basic infrastructure that is really not differentiating or controversial. And I think the more that we can have those basic pieces in MLIR, the more that it allows people to focus on their differentiating stuff, right? So FunkUp I see as a great example where 98% of uses they just need a function with arguments. And so it makes a lot of sense to just kind of have a standard way to do that is reasonably well thought out and isn't too extravagant, right? And then if you want to have something different, please go build something that's different and differentiating and does your specific way of having a FunkUp, right? And I see a lot of what we're talking about here as being kind of the same thing. Like a list is just a list. It shouldn't really be that controversial. And we don't have to get everybody to agree on saying this is the only way that lists can possibly be, but we have something that covers 95% of the use cases and is good for this particular machine learning use case, then by all means, let's go build it. Let's put it into the basic framework and then leverage it to go solve a machine learning problem and leverage it to go solve a whole bunch of other problems too.
I liked what Chris called it in one thread. They really built-in module on Funk are really sort of like starter, like starter module, starter Funk. And if I can reinterpret, Stephen, what you're saying is like there might be space for like a starter list dialect, and that, I don't know, potentially can dodge some of these issues.
And if we get to the point where we say, okay, we start wanting to put things in lists that really aren't kind of uncontroversial and generic and are more opinionated, then we go, okay, now I know what's different about my list, and maybe now I can start to build interfaces and concepts around how my list is different, and that will allow the basic framework to evolve, and also us to go solve these very specific problems around machine learning that I think we're motivated by.
I think Stephen made all the points I was going to make, but yeah, maybe just reiterating the same thing. It seems to me non-controversial that this would be useful for some people, but that's different than saying that this is something that we would want to impose on, all types of programs. Like I think it's, totally reasonable for somebody who wants to do hot word detection to not use this at all, and that seems valid. But then I agree, like I think once you get into the depths of like trying to encode all the complexity, I assume that this mushrooms into something terrible. But.
Well, and from my, sorry, go ahead, Matthias.
I just wanted to say, this is a point that Maddie has brought up in the discourse as well. Machine learning programs don't typically run on a single machine or on a single device. You have a handful of machines. They all have multiple GPUs. You have some kind of host loop thingy that drives all these machines and devices. So you need send and receive. You need message passing. You need some kind of asynchronous operation. Some concept of futures. Do we consider that to be part of the base layer, or is that some kind of extension that we want to put on top?
Stella, you want to answer that?
I think that we get some of the base layer set, and then we work on that. I think that the first intersection point where you're going to start to get into that territory is in your modeling of buffers and lifetimes. Or the that's the first point where you have a data structure that in every runtime that spans off of a host has a device field in it effectively, or has a memory space field in it, and that's one of the things that you need to do. And then you've also got lifetime attached to that and how you preserve that and communicate that. And so there's a lot of priors in that, but I think that's 15 miles past today's discussion. And I would probably start by taking a couple of the concepts and walking them forward, incrementally. Like I told Eugene, who you're working with on some of this too. I'm like, this process is going to go a lot slower than anyone wants, but I think it's going to have the best outcome. And then once you get to the slightly higher level of distribution, I think that it would be good to build a solid starter example of that on top of the primitives so that we can see it fresh and reason about it. Right now, when I look at this right now in every existing system, I can squint and see through it because I've been here for a long time, but there's not a clean layering. And I think we need to extract that out, look at it, and then design the next part as a future effort, my opinion.
Yeah, I mean, just to again plus one you, we need more high quality, really well thought out things. We don't need more things, right? And so, and just so people aren't confused, I'm not arguing against having a list type or something like that. What I'm arguing for is that be a different design project and it go into a different dialect that then composes correctly, and then you can pick it up and choose it, right? But even again, there's lots of different kind of lists. There's lots of different kinds of memory models that go with it. Do you want a value semantic list? Like there's all these questions that go into that. The thing that I think that would help lift this my opinion is that the ML program, and maybe I'm indexing on the title of the talk too much here, but in the circuit world, the HW module, like the basic container that then stuff goes into, Stephen, you can disagree with me if you disagree, obviously, but I feel like having that has been super useful for fostering community, right? Because what we have in the circuit world is we have, sure, it's the thing that then can export to Verilog if you use the basic stuff and it's good, but then people can innovate with, you know, interesting types in the ports. They can innovate in different lowering things that are going on, different elastic, dynamic, asynchronous, fancy pants stuff that all composes into there. And then having the container there allows you to do lowering and innovate in the offset. And so you can have 50 kinds of lists or 50 kinds of promises, futures that Matthias was talking about, like all this kind of stuff. But if you get the container right, then it enables you to lift the ecosystem. It fosters that within, in kind of like a way to collaborate, because you have the base foundation which to work together on.
So concretely to enable that, so I wrote down some things that, you know, concurrent invocations, linkage, program initialization, and I guess maybe allowable data types. I don't know, based on what you said, whether we want, how much we want to constrain that.
I would keep that open, but it's open in a very specific way, right? So the way that it works in Circuit is that, you know, and this is something that there's different takes in MLIR on how to handle the open extensibility. But again, just to use a concrete example from a different domain, right? The Verilog exporter in Circuit has more requirements on the ports, which are like the inputs and the outputs, the function arguments and return values of the equivalent of a func in Circuit than HW module does. And just to make it super confusing, a module in hardware is actually like a function. So, but and so the function abstraction is quite general, and so you can say, you know, conceptually throw an std string into the argument of this thing, right? Now, if you get down to the Verilog exporter, it's going to say, boop, that's not a supported type, can't export that, and you're done, right? But what the open extensibility allows you to do is it allows you to do lowering and different other kinds of things, and you can partition, and all good stuff can be done there. But it's constrained, and to your point, Sean, which I 1000% agree about, like you have to decide, is your func going to support a control flow graph, right? That's a pretty important thing if you care about the semantics of your function and all the code that runs against that, right? And so nailing that down and deciding, in the case of HW module, because it's a hardware thing, it's a graph region, right? That is a really important thing, right? And so the little things like that then enable collaboration, I think, are really important. And figuring out that, you know, HW module started very locked down, where we said, like, no, you can't define weird types for ports, right? But then we decided to expand that out, and I think that was a good decision. So iterative design also important. Anyways, all I'm saying is, like, simple things end up being complicated if you want to be really, really, really good. But again, +1 Stella's point, really good things you can lock in and build on top of. And so, you know, to me, it seems like a good thing to spend a little bit more time to find the right basic abstractions, even if it doesn't feel like you're solving the big problems.
Stephen?
Yeah, I guess my opinion is that the hardware module is really the standard func for graph regions. And there's a lot of basic compositionality concepts that you want to support for graph regions. And so, you know, I think it more comes down to, do you have a graph region or do you have a sequential region? And the HW.module is the unopinionated 95% of the time, this is what you want for a graph region kind of concept. So I think to me, I would think about an ML module as, what do you want to specify that's different from a hardware module, or different from a standard func op?
That's a little bit what I was asking. You know, like, so like, this is my list of, you know, on the slide is, but just to quickly get things out in the over video call, you know, is there anything else that, you know, we're missing here? While Stella and Chris are having their side discussion in the chat, to, like, I guess, yeah, exactly Stephen's point. Like, what value add are we having for ML program.module and func? Like, I mean, what we have here seems reasonable to me, but, like, is there just other thoughts on that?
Is it a graph region or is it a sequential region?
Mm. Okay.
Well, so in like simple bombshells like that question, I think are the important bits of this, right? Because that really does affect the outcome.
Yeah, and and I think that if you choose the graph region, then you're in a program. Well, this is an entire topic in and of itself, and there's a reason why in the original RFC I only included a module, because func is not an unopinionated thing. You know, a CFG func versus something that can be that can model a pure functional program with graph semantics versus something else. I don't know yet.
Can I, so to just maybe, we're joking about the naming and things like this, but if this were the unopinionated like base assumption that's intended to solve a lot of machine learning workloads and the standardizing thing, to me, the natural thing to name it is ML. Right? If you name it ml.func or whatever ends up being the right thing, ml.module, whatever ends up being the right thing, right? I think that starting from that thought space, I think puts new constraints on how general it has to be, right? So it's not just about enabling, again, I'm not saying you're saying this, Sean, but it's not just about like getting hot words so it could be like done. It's about standardizing this layer that is the non-differentiating layer that everybody else builds on top of, and you're licking the cookie with a name that makes it be the standard almost, right? But it also means that as a consequence of that you define other dialects that then mix in with it for the controversial things, right? And I think that kind of approach, again, that's exactly what Circuit did. Circuit said, like, we can't standardize add, like, there's too many different ways to add, right? And so there's a combinational logic dialect that composes on top of HW, right? And just like, and add is not super controversial, but you have, do you have unsigned semantics or signed semantics, or do you have like all the, like adding is actually, even such a simple thing is actually a little bit more complicated than people think about. And so if you scope it really narrowly and make it really solve that bottom layer, you could pick the obvious name, which then allows you to standardize the ecosystem, start zipping the community from the bottom up, right?
Yeah, it's I think that if we want to lick the cookie, we should lick it and then be activists and try to simplify the space.
Okay, Stella, I did not follow what licking the cookie means.
Oh, it's taking a name that is controversial and is specific, and in an attempt to lay down the basic abstractions concretely versus taking a name that is maybe less controversial, but is meant to be in a universe of other alternatives.
Mm-hmm.
Yeah, the way I'd suggest handling that tactically is set it as a goal for this thing to be named ML, but start out as ML something long, right? And that way we can iterate on the design, we can work through it, and then when people feel good about it and there's some usage experience, then boop, then you take the name, right? But yeah. Again, what I mean by naming is, I think that I would love to see it end up being called ML, right? Because I think that's the thing we actually need. And I think that would lift the community in a massive way. And so let's just make sure we do the diligence and set the bar right and make sure it's actually good, because the cost of standardizing something that's wrong is even higher than not having the thing. But
yeah, I would, my personal opinion is that I think that this is not one of the things that we ultimately just break down into its constituent parts and let live in the sea of public dialects. Like, this does need to be this is an important part of the industry. It does need to be a named space. And, starting with something that's ML underscore or ML dot something, I do think it's important to, like, say this, to be a part of that ecosystem. And I do like the approach of promoting into the more global bear word kind of thing. But I'm not saying this very well, but I just don't think that this is I do think that this needs to claim some space in the domain, and that's counter to some of the other intuitions that we've sometimes applied in the community of like do a first order factoring based on the type of the data type or something and whatnot.
Yeah, I mean, to me, success here looks like becoming the standard, right? And so
Yeah.
if you, again, the thing I'm trying to push consistently in this conversation towards is set your goals low enough that you can succeed at achieving the high enough goal of standardizing something for all of ML, right? And if you can do that, then again, you're making progress on, the whole ecosystem of ML. And it's small progress, but it's hugely valuable.
Suraj?
So I have a little bit of real world experience here, and I'd like to mention that I agree with a lot of this conversation over here, and I'd like to add to that. We've been faced with instances where we get a model. It could be some kind of a pre-built protobuf, fat buffer. It could be an MLIR form, and the same thing might be in different settings used entirely without the help of any kind of deployment-oriented IR or a glue code or anything to make it work. Or the customer may have their own an image signal processor or some kind of voice input thing for which they have their own deployment code that need to tie together. So it's functionally possible that the same model may run totally standalone without any help from anything, or may need substantial help to integrate, sort of break things out, as Matthew has just mentioned, needs supported on a multiple device instance. So it should be possible to take something like this and have what we're proposing here potentially break down the kernel or the program or whatever into a more deployable set of pieces that can be run more efficiently on whatever the use case happens to be. So that's a real world thing we have tried to solve and have actually had to solve.
So I think I was what you're getting at is have more of these fundamental pieces nailed down, make sure that they compose to the bigger problem effectively.
It could be extensible, yeah. It could be extensible. They might come with different things, and it could be sort of a general grab bag glue sort of thing that can work together with what's the traditional idea of an ML model.
Yeah. So I completely agree. Chris, since we're out of time and others, I think that we have trouble getting this kind of thing going. Do you have any more advice, or should we have another meeting and talk about like tactics of how to do this? Like we've had a couple of failures to launch on this topic in the past, and
well, so I think you have all the ingredients here. So I mean, I think that my advice on this is you say, here's a proposal. We want to name this thing ML. It's going to have a module, a func, an external constant. That's it. And then define, here are the requirements of semantics. Let's debate graph region or not. Let's work through the design space in that. I would say land it in the tree early, and so that we can iterate on the concrete code, not as a theoretical thing, but name it ML underbar program or experimental ML or something. And then in a month or however long it takes, I mean, maybe that's overly ambitious, but in however long it takes, as the design settles down, then we say, hey, does this seem like a good thing? Have people used it? Have you adopted an ERI or whatever signal makes sense? And then, it doesn't solve all the world's problems, but it's valuable. Then you say, boom, this is ML. Right.
Okay.
And then you say, cool, let's go talk about lists. And say, okay, well, what are lists? Blah, 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 blah. Let's have a list dialect. Let's throw some types in there. Let's throw some ops in there. Is there one kind of list, double-ended, like whatever, right? And however that conversation goes, and that can be a new thing. And it's a set of types, ops, whatever, that then compose with ML. And people who want to use lists can use that thing, or they can invent their own or whatever. And maybe at that point it's called ML list because, again, the global nature of dialects. But having ML be short, I think allows doing that kind of thing. And I think that if you look at it not as, if you look at it as an ecosystem of dialects that compose well, I think that then you can solve the big problems that, Matthias was talking about, and you can have a futures dialect, or you can have like all kinds of cool things over time. And then you get a people can pick and choose what they want to use or what they want to replace, and you get high leverage without having to force opinionated designs on folks.
Yeah, that makes sense. Thanks.
All right, we are out of time, so it sounds like we are ready to. It sounds like the action item. Stella, can you, I don't know, somehow reboot the conversation in light of this? And
Can I pass the baton to someone else to reboot the conversation this time? Because I think I'm using some of the wrong words. So it's
Well,
Sean, let's talk about.
I would start by just start with the design doc. Like if you say, here's a design doc and do that, I can help you with the editing it and things like, or I can help anybody with the editing it and things like this, if that's helpful. But I think that just being very specific about a narrow goal, it's like motivation, narrow goal, let's unify this like tiny part of the ecosystem that is nevertheless the foundation for everything that gets built on top of it. And then say, so what we need are 4 ops. and here's the design space for these 4 ops. Here's the trade-offs. Okay, somebody wants a crazy func that has like recursive blah 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 something or other. Okay, well that's out of scope. They should define their own op for that then composes into the same model, right? And so as people have objections to it, we'll both learn and iterate the design, but then we'll also decide what are the bounds between the things that get standardized and the things that become, you know, the world is sufficiently weird and there's a lot of complexity in it, but it doesn't all have to be in the standardized thing, right? And so that line is unclear, but we'll work through that as a community.
Okay.
Does that approach make sense to you, or?
The approach makes sense to me. I think that I'm probably adding superfluous words that are triggering people when I don't mean them to be part of the initial discussion.
No, I think that, I mean, just give you my opinion on this. I think that you and Sean are doing an amazing job of trying to drive progress here. Right? I think this is hugely important, which is why I care about it. But I think that the challenge is always that ML is big,
yeah.
Right? And everybody wants to solve the big problem. And if you look at where MLIR came from originally, it was saying like, okay, there's, you know, all of these compilers are big. There's all these big things. Let's standardize the thing at the bottom, right? And by standardizing the thing at the bottom, we lift the world. I feel like this is a similar kind of a situation where if you reach too high, you won't make progress because again, you enter all the complexity of the design space and like
right.
You enter all the opinions and you get all the crosstalk and things like this. And like, how should I do hot word detection? Well, that's a different, like all the different things. And so
yeah.
start with less controversial, non-differentiating, as Stephen says, but nevertheless the foundational piece.
Yeah, I think that where I've possibly taken this off the rails is the you know, I've also gotten the other feedback of enunciate the end state, and you know, I'm like, I don't want to, and by enunciating the end state, you almost like then everyone indexes on that, but you almost need to have enough of a span to justify taking you know, a big name kind of thing. So anyway, this is good advice. Thank you.
Yeah, and
does this need to be generic to be successful? Like, do we? I can totally imagine parts of this being in an ML namespace, but like, I could also imagine this being immensely successful if we did something as dumb as calling it the Python dialect, and you're like, hey, look, this is, and you know, has a lot of opinions on it. It's also really, really useful, and you can use it. And it turns out that, you know, that's how people are doing ML, and that's how they want to be able to express their programs.
So I think
I have to go. I very much disagree. I very strongly disagree with that. And I think the key thing, my parting advice as I run is look at the HW dialect. The HW dialect is super useful for unifying a different community, and it has almost nothing in it. and so like if you achieve that level of success for ML, that would be amazing. And then you could allow lots of vibrancy, and you can allow people to be Pythonistas if they want to be Pythonistas, and you can do lots of cool stuff. But anyways, that's my opinion. I've got to run. Thank you so much for driving this conversation. Right. This is great.
All right, awesome. Thanks everybody for joining. So
sorry, Russell. You said Python.
I said the wrong thing. I was trying to be non-controversial, and apparently it made it worse.
It turns out Python